You are false images, faces of radiant flame, heart's warmth and tenderness and soul you cannot claim. Karl Marx, Song to the Stars, 1836. In the many drawings that Dutch astronomer, Marxist thinker, and council communist Anton, Pannekoek, 1873–1960, made of the Milky Way over the course of his life, it is not immediately clear what we are looking at. The band of stars appears like a smudged backbone, sometimes in true color, white stars on a black background, and sometimes inverted, with the stars as dark points and the milk of the Milky Way made inky. They are simultaneously vague and precise, something between a charcoal rubbing and an X-ray dot. In fact, the drawings are not technically of the Milky Way at all, because according to Pannekoek, such a thing was not actually accessible as a purely objective entity. While it was widely understood in Pannekoek's time that even highly skilled astronomers fall prey to observational bias during stargazing, a phenomenon known as, Pannekoek went further, theorizing that what we perceive as the Milky Way is actually a visual trick that emerges at the intersection of the stars and the people on Earth who perceive them. During an article published in an 1897 issue of Popular Astronomy, Pannekoek discussed the well-known problem of the Milky Way's ocular inconsistency, wondering if the character of the galactic phenomenon precludes its being fixed by delineation. This was not just a failing of observational science, it reflected what the Milky Way actually was, a kind of optical illusion that changed its shape depending on the lived experiences of the observer, their historical period, and how these experiences informed the patterns that the mind constructed out of the fluid nature of reality. Pannekoek's drawings, then, are of the act of perception itself, an approach informed by his political beliefs. Like Marx and Engels, who drew on Feuerbach, Hegel, and Heraclitus, Pannekoek understood material reality to be a continuous and unbounded stream in perpetual motion. He also believed that the human brain had a tendency to generate fixed, abstract patterns from this fluidity, patterns that are always socially and historically contingent. Any view, including that of the stars in the sky, was therefore always making and remaking itself in the mind of the observer according to their individual physiology, psychology, and the distinct material conditions of their place and period. As technologies for image making, such as trained on the Milky Way, become more advanced, mechanical objectivity does not necessarily become more trustworthy. The history of astronomy has been commonly narrated through the technologically determined progression of better and increased vision, Anya Ventura. Yet because these technologies rely on a form of data gathering beyond the faculty of the human senses, there are always additional processes needed to transform their findings into something we can experience. These processes, often excluded from the public-facing narrative, are shot through with subjective decisions. The rich milky vistas of turquoise, rust, violet, and crimson that populate NASA's first Hubble telescope photos, for example, were artificially colored, much to the disappointment of a public who felt they had been tricked. That artificial colors allow viewers to visualize what ordinarily could never be seen by the human eye. As Lorraine J. Daston and Peter Gallison have argued, scientific imaging's objectivity rests on a construction of the naked eye as deeply unreliable. Pannekoek's drawings, by contrast, produced during a period in which the mechanical eye was overtaking the traditional role of handwork in astronomical observation, represent an alternate current in astronomical image making, one that does not shy away from the inherently contested and personal nature of viewing space, but builds this contestation into its very method. This way of doing science does not deny its embeddedness in the material and historical conditions of living on Earth. Born in the Netherlands in 1873, 25 years after the publication of the Communist Manifesto, Pannekoek studied mathematics and physics at Leiden University, publishing his first paper on the Milky Way while still a student. He became interested in socialism upon reading Edward Bellamy's utopian novel, 1897, after which he began to study the philosophies of Karl Marx and Joseph Dietzken. His scientific and political careers proved difficult to reconcile, and he eventually left his job at the observatory after he was reprimanded for supporting a strike. Deciding to devote his life to revolutionary politics, he moved to Berlin and then Bremen, where he published widely, often with a pseudonym, and taught classes on historical materialism at schools founded by the German Social Democratic Party, SPD. He had an intercontinental reach. In the years before World War I, Pannekoek's name was familiar to many American socialists when Lenin and Trotsky were virtually unknown, notes Theodore Draper. After World War II, disillusioned with the communist states, he became one of the main proponents of a current of thought that opposed state socialism, and instead advocated for a revolution led by the workers' councils. Despite receiving a favorable treatment in Lenin's The State and Revolution, 1917, Pannekoek is perhaps best remembered politically for his 1938 Lenin als Philosoph, Lenin as Philosopher, which critiques the revolutionaries' belief in the reality of abstractions. Pannekoek returned from Germany at the start of World War I and found himself once again at Leiden University, where he gradually resumed teaching duties. After a change in the university's directorship, Pannekoek's name was eventually put forward for vice-director of the observatory, but his known communist activities meant that the Dutch government, fearful of the tide of communist revolutions sweeping across Europe, vetoed the appointment, as though his propaganda activities might be a risk to the stars. In 1921, Pannekoek established the Institute of Astronomy at the University of Amsterdam, which bears his name today. Around the time he was first dismissed, Pannekoek had described the university's methods as tedious and outdated. Astronomy at the turn of the century was committed to its self-fashioning as a precision science, and doubled down on its acknowledgement of the personal equation problem by building vigilance, monitoring, and bookkeeping into methods. William Ashworth describes this as an accountant's view of the world. Pannekoek, by contrast, argued that the Milky Way was produced at the intersection of physical reality, the observer's eye, and the way their mind interpreted this interplay. In A History of Astronomy, 1951, Pannekoek asks, "What really is the Milky Way? Exactly speaking, it is a phantom, but a phantom of so wonderful a wealth of structures and forms, of bright and dark shapes, that, seen on dark summer nights, it belongs to the most beautiful scenes which nature offers to man's eyes. It is true that its glimmer is so faint that it disappears where the eye tries to fix upon it. It is perceived only by the rods, not by the cones of the retina, hence is seen only by indirect vision, yet, when all other glare is absent, it gives an impression of brilliant beauty because of the faintness of some stars that made up the sparkling band of the Milky Way, and the unpredictable way in which the human eye received their light." Pannekoek believed that the brain, which tended towards abstraction, found its own patterns in the interplay of light and dark, and that these patterns would be different depending on the distinct life experiences of the observer. Pannekoek devised a method to produce what he termed the mean subjective image of the Milky Way, which was comprised of multiple, layered perspectives. To achieve this, he collected accounts of the Milky Way perceived by several other observers, initially as written descriptions, believing that sketches were more likely to lose their accuracy in the act of drawing, and later also as extrafocal photographs, where the plate was intentionally placed outside of the focal plane so that light was distributed more fully, mimicking the way astronomical light is perceived by human eyes. Both the written accounts and extrafocal photographs were translated into isophotic maps, which correspond to the intensity of light, similar to how topographical maps capture the height of terrain. A line was drawn around an area of equal luminous intensity. Each line was then ascribed a value. The mean subjective image was produced by finding the numerical average of each shaded line. Once the average had been calculated, the maps were made into drawings by Pannekoek himself. From today's perspective, there is something deeply alien about Pannekoek's inverse maps of the Milky Way. The shadow at once carefully contoured and vague, like the marks a crumpled bedsheet might leave on morning skin. They are naturalistic but not photorealistic, because the method of their production involves a distrust of the photographic eye's supposed objectivity. These images address themselves towards something that is inevitably elusive, an average of various human and mechanical visions, and yet they do so with intense care and rigor. Working at a time when all industries were increasingly mechanized, Pannekoek did not necessarily champion the replacement of written accounts with machine-based methods of perception, but instead sought some form of collective subjectivity by bringing together different organic and mechanical ways of seeing. If much of the history of post-Enlightenment techno-science can be explained as the quest to mechanize vision in order to increase its precision and accuracy, then Pannekoek was moving in the opposite direction, distorting the camera's gaze in order to bring it into closer proximity with human sight. While Pannekoek strived to separate his political and scientific careers, those who have studied his work closely, including Omar Nassim, and observe the ways in which his political beliefs bled into his scientific convictions and methods. Pannekoek's notion of the Milky Way was essentially Marxist in nature. In a pamphlet titled Class Struggle and Nation, 1912, for example, he describes a version of historical materialism influenced by Dietzgen, which endows perception with profound importance. The external world flows before the mind like an endless river, always changing. The mind registers its influences, it merges them, it adds them to what it had previously possessed and combines these elements. Writing on a similar theme in 1944, Pannekoek described thoughts as not independent entities but instead connections and interrelations that were defined by a dynamical process of movement, and which were entangled with material conditions. For Pannekoek, then, the mean subjective image of the Milky Way was less a static average than a process that captured the dynamic nature of thought as it related to observation over time. It was an instant or snapshot of the wider flux that constituted all reality. In Anthropogenesis, Pannekoek refers to the human ability to find patterns in terms of a smoothed average, an automatic process of organization by which sensations would influence conscious thought by heaping up in the dark depths, gradually smoothing out and amalgamating. This meant that the more one was trained in a specific discipline, the more the patterns they identified would correspond to what they had already learned. What Pannekoek was talking about could now be called confirmation bias, although in the context of a wider belief in the material origin of thoughts, Pannekoek was referring less to an unfortunate human fallibility, more to a fundamental aspect of the way we relate to the world. Scientific practice in the late 19th and early 20th centuries was still largely funded by private wealth, and an undercurrent of social Darwinism drew a link between bourgeois upbringing and innate scientific talent. Pannekoek staunchly opposed this notion in Marxism and Darwinism, 1909, where he tries to demonstrate that, although Darwinism served as a tool to the bourgeoisie in their struggle against the feudal class, in reality, Marxism and Darwinism form one unit. For Marx, Darwin's work introduced dialectical thinking into the natural sciences, troubling previous conceptions of the natural order as a fixed, stable chain. As Tai argues, Pannekoek also rejected the commonly held 19th-century idea that scientists possessed excellent vision, an innate knack for observing things exactly as they existed in the real world. Pannekoek's belief in the material foundations of ideas meant anyone could learn to practice science. If the tools to do so were owned by the proletariat rather than liberal scientific institutions, then science would no longer be dominated by the bourgeoisie. In a capitalist society, Pannekoek, science is the privilege and the specialty of a separate class, the intellectual middle class, whereas in a communist society all will partake of scientific knowledge. Pannekoek's disavowal of the idea of special scientific genius did not discount the value of acquired technical skill. Omar Nassim has the way Pannekoek's scientific practice centered on craftsmanship and handwork, what Nassim calls a strong, operational presence of the hand, highlighting how different forms of labor are involved in the production of scientific knowledge. In this sense, too, Pannekoek brought down to earth the mystified discipline of astronomy, which, as Nassim writes, does not have the luxury of having its objects near, highlighting the material conditions that made astronomical ideas possible. Though Pannekoek lived and worked two distinct lives that he was never fully able to reconcile, he is increasingly remembered now as a Marxist astronomer. The resurgence of interest in Pannekoek's dual pursuit seems tied up with an increasing awareness of how science and systemic violence intersect, prompting the question of how we might do science differently. What might a science informed by socialist politics look like? And where are the Marxist scientists today? Modern astronomy is far from a politically benign pursuit. Its development in Europe is closely bound to the emergence of systems of global data collection, mapping, and standardization that exploit material resources from across the globe while also positioning Europe as the intellectual center of the world. As Alex Sujin Kim Pang argues in Empire and the Sun, Victorian solar eclipse expeditions, astronomical research became a way for European countries to impose Western scientific norms and beliefs as objective truth. It was common practice for European universities to build observatories in colonies in the southern hemisphere, which offered a different view of the night sky. Pannekoek himself benefited particularly from colonial infrastructure in Java and Sumatra, at the time part of the Dutch East Indies. Nevertheless, the philosophy underpinning Pannekoek's work, when examined critically today, might be said to contribute to a current of scientific thinking that subtly undermines the forceful imposition of certain worldviews over others that has largely been the legacy of colonial knowledge production. A dialectical view of the night sky opens up a path beyond any absolute binary between truth and falsity, evoking a form of scientific rigor and precision that does not aim to present itself as complete or incontestable. Pannekoek's drawings therefore hark back to an earlier form of astronomy which, as Charlotte Bigg writes, embraced a qualitative, literary and aesthetic approach rather than a quantitative, mathematical approach to phenomena. By foregrounding interpretive variety, Pannekoek edges towards a more bottom-up and decentralized way of doing science, one that has the potential to complement anti-colonial and anti-capitalist methodologies. It was their quality as aesthetic objects that first captured my interest in Pannekoek's sketches, and I'd guess that this is also what has helped these sketches to endure. The aesthetic realm, for Pannekoek, was a manifestation of the way in which the human mind is able to build order out of the disorder of the cosmos. As Johann Hartl writes, this idea of a profound isomorphism between cosmic order, nature, human society, and even the individual subject, held the promise of a society based on a self-regulating system of material forces. The Milky Way images, then, are not images of the sky so much as cosmic mirrors for the human subject, revealing the interplay between the individual and the collective, between thought and matter, and the deep correspondence between art, science, and politics. The works of Anton Pannekoek are not yet in the public domain in countries which follow a copyright term of life plus 70 years, for example UK and most EU member states, and only those works published prior to 1926 are public domain in the US.